The broadcast is now starting. All attendees are in listen-only mode.
Hello, thank you so much for tuning into our webinar today. My name is Monique Anderson. I will be your host. We are fortunate enough to have Andrew Leedy, an application engineer for PTC, here with us today to talk about additive manufacturing in Creo 4.0, as well as Hamed Yazdi, who is the business development manager for Tech30. I will now hand the reins over to Hamed.
Thank you, Monique. Welcome, everybody. This is Hamed. And what I want to talk about is a little bit about our company and our services that we provide before we hand it over to Andrew to get into the presentation. So our mission at Tech30 is to essentially help customers solve their engineering challenges. And this is by providing innovative software, the engineering services, as well as training and support. Our goal is to really become your partner. We don't want to be just a software vendor. We want to be a solutions provider in any way that we can, including helping you expand your network. You know, one of the things that I really enjoy about my job is when I can identify customers who can help each other out and make those introductions and help us all grow our businesses. So please give us the opportunity to get to know you and see where we can add value to your business. So let's talk a little bit about the Tech30 portfolio and what we can provide. So on the software side, specifically with PTC, we support and sell Creo, Windchill for data management, MathCAD, as well as Arbortext for technical publications. We also have partnerships with Solid Thinking as well as Siemens. If you have any of those needs, you can come to us as well. On the hardware side, we sell 3D printers, which I'll talk about a little bit more in a couple slides here because it's relevant to our presentation. And then laptops, we sell laptops, we rent laptops as well for trainings. Now the services is an area that we really focus on. Our bread and butter is PLM deployments. We'll do customizations, architecting, upgrades, data migrations, specifically for Windchill and Teamcenter, helping you optimize your environment for your business needs. We also provide training as well as engineering services such as analysis and modeling. So now let's talk a little bit about the 3D printers because it's relevant to today's presentation. I'm going to go very quickly. We sell two printers. We partnered with Markforged and HP. Markforged creates very strong parts, the strongest polymer parts on the market. Now, before in the past, the mentality with 3D printing is that it's really for prototypes, just to see what your product looks like. Now people are demanding more for 3D printing, and the technology is finally there where we can produce functional, strong parts. What Markforged does is their printers are very unique. They have two print nozzles, one that prints a base material. That base material is either nylon or onyx. Onyx is nylon with crushed carbon fiber, so it's a little bit stronger. You can see on that graph there at the bottom. And then it has a second nozzle that can print reinforcing material, and the materials that are currently available are Kevlar, fiberglass, and carbon fiber. So the strongest combination of these two materials is when you put onyx with carbon fiber, and you can see in the stress strain graph, you're getting the strength of aluminum with the flexibility of a 3D printer. And it's very economical, starting at just $13,500. Moving on to the next slide, we also are getting into metal printing. Currently, stainless steel is available, and in beta testing is titanium and aluminum. So now let's switch gears and talk about the HP unit real quick. Now this is really for production or low volume production. We can move to the next slide. The HP unit is really for low volume production printing, meaning we're talking hundreds or thousands of parts in a week. So it's really for specific customers looking for speed and really kind of bridging the gap between manufacturing and getting the economies of scale. So those are the solutions that Tech30 provides in terms of hardware. If you have those needs or would like to learn more, please feel free to get in touch with us at the presentation. So now I'm going to hand over to Andrew, and he's going to go over the additive manufacturing extension within Creo.
Okay, thank you, Hamed. Thank you for that introduction. So my name is Andrew Leedy. I work with PTC. My job is to do high-level overviews of various Creo extensions, and today the extension we're going to be looking at is the additive manufacturing. It's new within Creo 4, and it's very exciting. So before I touch on the capabilities of what that's able to do, I really like just take a step back and see where we're coming from, why this extension was added in Creo, and why we feel it's necessary. So 3D printing is a revolution in the world of manufacturing. You're able to have custom production parts built in very difficult traditional geometry or non-traditional geometries. And your robust CAD models are the start of this entire process. Good CAD design leads to good print. But many times existing CAD systems just do not address the challenges of this new technology. CAD and additive manufacturing are seen as separate domains. So you build your design within one software, you save it off, you send it over to your splicer or your Catalyst software, and then that's how it's able to get to the 3D printer. There is just a clear disconnect there. We also might not be able to create additive manufacturing specific CAD features. So things such as lattices and being able to put support materials. This is something that is not supported traditionally within CAD. There is also no printability checks within CAD. If anyone's gone into doing your 3D printing, you'll know this scenario is all too familiar. You have something that looks like it works within your CAD, you go to print it, and then you just get junk, something messed up, something collapsed, whatever it was, it did not work out. And that's because there was no printability check before you did that. There was nothing to say, this is not gonna work, I cannot 3D print this. So many times, there's a lot of different software packages that we're going to be using. We might have one to put in your 3D lattices. You're going to have one that's going to do your printability checks. You're doing one to design the 3D prints. So you're going through all these different avenues just to end up with a first-time build success on those 3D prints. Well, what we've done is we've taken a lot of that, put it into Creo so that we have all of that within one software. So that's what our solution is, Creo Parametric 4.0 Additive Manufacturing Extension. Now, getting into some of the capabilities of this, PTC is partnering with key 3D printer manufacturers. So those key 3D printers are Stratasys and 3D Systems. So there's a few supported printers from each of those. And the goal is to streamline our 3D printing workflows within PTC Creo and integration with those 3D printers. Now, traditionally, our process basically looks like this. So we have a first iteration. We start with our 3D model. Then we send it off to the optimization technology, the topology optimization or the lattice creation to reduce our weight. Then we might send it off to another piece of software to simulate and to 3D print check. And then we do our build. Then we find out there's something I want to change. So we go into the second iteration. We rebuild that geometry, re-optimize, re-simulate. I think you get the picture here. We do the print validation all over again and then do that second build. So what do we get from the results there? A lot of multiple disconnected models, and I had to leverage many different types of software to get to that point. And if there's a design change ever, well, we get to repeat that entire process. So here at PTC, we think that there is a better solution, and it looks like this now. Design, optimize, validate, and 3D print check without leaving Creo, and all have it have associativity through everything, so that if there's ever a change, I can make sure that there's going to be a less amount of rework going back and modifying and pushing that through. So new within Creo 4.0 is the ability to have this additive manufacturing extension, and the new capability there is added in Lattice. So something that is not as supported within CAD, being able to put in very 3D printing specific additive manufacturing specific features. So being able to say, I want the entire inside of this to be a lattice. I want to reduce the weight, reduce the amount of material I'm using, but keep the same structural strength. There's a lot of different ways on how we can apply the lattice. In this case, we have basically a shell on the outside and lattice is residing inside. We can also go through and say, well, I want a lattice without the shell. So just replace entire structures. So I've seen, full cylinders of this. We actually have a demo where an arm is made just completely out of lattice instead of just using a solid shape, really cutting down the material there. Going through, we have some extra support for not only 3D lattices, but also just standard 2D lattices, stuff that your 3D printer the Catalyst software, the Splicer software is already applying, but can be applied within Creo now. And the whole goal here is to reduce the mass here, make sure that we have the same structural strength, but we're able to go through, add those lattices in, and cut down on some of that material. And also making sure that we can build the lattices in the manner that we want, have greater control over how this will print and how that lattice will be applied. Going further than this, we can even pair this up with any other Creo extension, and in particular, what we're going to be going through in our demonstration is pairing this up with Creo Simulate. So take my model, do a simulation of it. We've already reduced the mass a little bit, and then let's optimize it. Let's get an idea of our design limits, and then let's run through and say, have the system tell us what size cells we should have and all the different various lattice parameters, and do that change, push it through, and see what we get out of that. As I said, PTC is partnering with Stratasys and 3D Systems with the goal of streamlining that 3D printing workflows. And there's going to be support for additional printers planned out. As I'd said, since this was already made, 3D Systems has joined that lineup, and there are other printers scheduled to be deployed with this as well. So now our process revolves around adding in our 3D printer, getting a direct connection from Creo to that 3D printer. If it is a Supported printer, we can actually direct entirely to it and print directly from within Creo, skipping the entire need of going through a splicer software. Or we can, if we don't have a 3D, if we don't have a supported printer, we can go through and just set up a generic printer with the certain print layout that we have, set up our minimum allowed gaps, the minimum wall thickness, those different variables that we are concerned with, making sure that we have a first-time print success, laying out our tray within Creo, and then printing it off as an entire STL and get that over to our software. But we've already done the setup beforehand in that 3D space where it's a lot easier to see. That's, as I said, set up all the different options we're concerned with. Go to that prepare for 3D printing where it's going to bring out our tray, and that's where we say what our scale is going to be, what STL resolution are we be working at, position everything accordingly, display the support material, and then check the printability to verify that this is going to work. Now for supported printers, we also have the ability to choose what color we want to print from directly within Creo, choose our surface finish, and also see our build time. Now that's all I have on the capabilities of the software. I really like to jump into this now and show you how we be able to build out some of these 3D additive manufacturing specific parts and how we prepare a 3D print. So here we are within Creo. I have a general model here, and we're just going to be working through this. So the first thing I'm going to do is blow out the entire inside of this. So this is going to give me an area to place my lattice. As I said, there's a lot of different ways that we can apply these lattices, but one of the most simple is just say, I have a blank space in here, let's put a lattice in. So what I can do is go up to engineering, down to lattice, that's our new button there, and then I can go through and just select a surface that I want to start applying this onto. So this entire inside surface, we can grab all of that to box our lattice in, as well as grabbing the front and the back. And then just as easy as that, I have a full enclosed surface. We choose what size lattice we want from here. I can go through and preview this and see what we got. So just before I even go through and actually see anything, see, I didn't select my back boundary here. So without even going through and customizing how this lattice is going to be made, it's just going to generate this automatically for me. Now I have a lot of control over how these individual lattices are made as well. So if I see I have some dangling beams here, and maybe there's too many beams, I don't need this much, I want to cut down the print time, I can go through and actually go down to the cell, individual cell level, and customize how these are going to turn out. So maybe I want to remove my inner horizontal beams, and I want to remove my dangling beams, and then we can see what we get generated from this. So just going through and getting down to the level of detail that I need for this. Now, we have a lot of different ways on we can apply lattice, 3D types of lattice. We also have the support for 2D, and we're always given a preview of what that lattice is going to look like on the side there. So we want to orientate this in a different direction so it's actually doing something. And otherwise, let's just preview this, see what we got. So very simplistic type of lattice. And then maybe we want to go through, choose from a regular, quasi-radial, herringbone. So just saying how those lattices are going to be oriented in the general shape of those. For something like this, if I have this entire thing closed off, we might want to go through and add some drainage holes. So we have the support to add drain holes and just customize these a little bit further. But for the purpose of this demonstration, we'll use this regular 3D lattice. And there's the quasi-radial right there, but we'll just use the regular and go from there. So now we can get out of there, get out of that lattice generation, and we have something we can work with. Now I could go straight from here into my 3D printing, set that all up, set up my tray, and get this out and get this prototyped. But I want to make sure that this is going to work on the first try. I don't want to waste all the time printing it out. It might take a while, depending on what 3D printer I have to actually get this printed. I want a bunch of these. Let's make sure it's going to work before we get that. So what I can do is utilize some other Creo extensions to do that. And one of those is simulate. So for the purpose of simulation, we actually have this button here. We can go from a full geometry down to a simplified. So a simplified geometry allows everything to remain intact, but for the computer's sake and for the system's sake, let's make it a little bit more simplified to actually go through and do those simulations. So before I do any simulations, I always want to go through, put down a material we're using. So if you guys are unfamiliar with Simulate or you haven't seen before, we have a large library of materials that we can choose from to do those simulations. So we're just going to be doing a general plastic here, and then go through, find my applications, and go into Simulate. And we're just going to be doing a very quick setup here, just because the focus is more on the additive manufacturing, but this goes into it a lot of the time. So setting up my displacements really quick, setting up a force that we're going to apply. We want to apply a force from down on the side here. I want to go through and say that this is going to be a certain value for my X, a certain value for my Y. Just going through and doing some normal setup, maybe change my units around here as well. So now I have a load applied to this. I have an area that we're holding this down. Let's go through and run an analysis. So I can go through and say, well, let's do a new static analysis, just as a very simple idea. Give it a name, say what type of method we want to use, single pass, do a multi-pass. Otherwise, we'll just do a standard one. We can go through and actually run this simulation. As we run any simulation within Creo, I can always just pop up this dialog just to see what it's doing. And since we simplified that lattice down a lot, it's going to go through and do this pretty quick. And it's already said that we have a run complete. And just to show that what we can get from this, we'll just view our results. So we can take these additive manufacturing, these lattices, and take them into Creo Simulate and get some really good information on if this is going to be a printer, if this is going to work for our particular use case. So going beyond this, we can even go further with Simulate, and I might want to do an optimization of this. And I won't do the full optimization just because it's going to take a little bit of time to do the full lattice optimization. We actually have one saved off as well. But I can go through, say, what's my goal here? I want to minimize my mass, apply some design limits. I want to minimize my max displacement in the X direction. Then I go through and just start selecting on some variables. And I can select on all these other variables within my model, but particular with the additive manufacturing extension, let's actually modify our lattice. So I might want to choose on the height of my cells. And I can just keep going back in here and just grabbing all these variables. I can do one variable, I can do all of them, whatever I want to do to get a fully optimized part, whatever I want to go through and change. So now I have this all set up. I could say, well, system, run through, change all these over a curtain range. So I have a minimum and a maximum and my initial. Let's change all these initial ranges to the minimum, to the maximum, see what works best to achieve my maximum displacement of less than a certain value that I want to put in. Now, as I said, this is going to take a little bit to run that. So I actually have this already prepared, so we don't have to wait on that. Have our optimized model in another saved file here. So we can go through, take this. This is a simplified lattice as well, so changing that back into the full geometry is as easy as editing the definition and just go from there. So as it regenerates, we can see now we have a fully optimized part. It took that goal of minimizing my maximum displacement and just changed things with the lattice. It went through and did a bunch of iterations of this until it came up with a fully optimized piece. And it can even optimize down to the individual lattice level here. So close to the center, we have some larger, thicker lattices where it might need some additional support, and then where it might not need as much, where the loads might not be as important, it's making those lattices a little bit smaller. So get a fully optimized piece within Creo. Now going from this back within actually caring about this, get this over to the 3D printer. So we can go through and do a prepare for 3D printing. Now before I go over there, I talked a lot about, let's customize this to making sure that I can link up to a printer. And if I don't have an actual printer to link up to, let's go through and just have a general layout where it saves off my tray size. I just want to set up my tray, get that over to my 3D printer, but set it all up within Creo. So I can choose from my 3D printers if we have a lot connected. Otherwise, I might just want to add a new one. As I said, those supported systems are going to be Stratasys and 3D Systems here, but we can always add in another one if we want and just say, let's make it X, Y, and Z, however tray dimension size we're currently using. What type of technology are we going to put down so that it knows how to, if it's going to put support material, what type of support material it's going to model out. And we can even put down what that printer name is and link up to that URL. So once we've selected one of these, we have it all set up, we can go through and say for the printer validation. So this is where we're concerned with the minimum allowed gap that we want to allow whenever I run a validation check, the minimum wall thickness, because these are all types of things that are going to lead to a failed print. All printers are different. There's a lot of different tests you can do for your printer to find out what these values are going to be and what type of precision your printer is able to print at. So you want to make sure that you're able to change this for every printer that you're going to be using. So going from here, as I'd said, we can do that print, prepare for 3D printing. So this is where we can actually set that tray up and manage all the different STLs or all the different models that we're going to be putting in. So first thing I might want to do is make sure that this lays flat on my tray. We can just auto position that into its position there. And then I can go through and start doing all those different printability checks. So first thing I might want to do is, let's do a validation check. Can I print this? So go through, we have that optimized finger here. Let's compute how it's going to react to this minimum wall thickness. And I don't have this particularly calibrated to a certain printer, so it's going to come back and it's either going to say that it's good or it's not. In this case, it's going to say, well, we violated a rule based off of the parameters I put in. So I either need to go back and change my model around, or I need to go verify that these parameters are correct. But otherwise, we're getting a lot of information on, should I even try to attempt this print? So right now it's saying, well, I wouldn't attempt that. You're not going to get a good print off of that. We can even go through and start laying out additional things here. So I might want to print off a bunch of these. We're going to be using this all around my shop. Just use standard Creo patterning techniques and going through and just placing more than one down. Now, as we start putting more and more onto these trays, another check that a lot of those different splice or catalyst softwares do for your 3D printer is verify that you're not going to have anything running into each other, that it's going to be able to print off and it's not going to combine all these things. It's not going to combine support material, whatever we're trying to do, that it's going to come out with a clean print. So as we can see here, this is pretty obvious, but many times whenever you lay these out, you don't get an obvious mistake here. But we can see that a lot of these pieces are running into each other. So regardless if we have an obvious mistake there or not, I can go through and just say, well, let's pick out a global interference, have the system run through and make sure that nothing's colliding. We can see in this case, part 1 and part 2, and going through, obviously we have 2 more iterations of that as well, since this was patterned out in the exact same manner. But we have 3 fixes that we need to go through and fix before I can print this off. And I can just do a simple auto position or move those around to whatever area I want if I want to do this a little more manually. Now from here is where we'd also set up, if I have a supported printer, how I want to manage my appearance. The surface finish, if I want to apply a different color, if we have a printer that supports that, as well as being able to calculate our build time. So being able to see or get an estimate of how long that particular printer is going to take to build this. So if you have a supported printer, that can be done all within Creo. Otherwise, regardless if we have a supported printer or not, if we're just going to save this off as a full STL, I can go through and preview this for 3D printing. Now, depending on what type of 3D printer we're going to do, this is where we go through and display our support material. How is this going to build? And I can get down to a level of detail and be able to see, do I have any problems here? Is there anything I can do to reduce this amount of support material? Maybe I want to make sure that we don't have as much, whatever I want to go through and doing that. I can also clip this model to get down to, an extra layer of detail in my model, see specifically what it's trying to do here to build this out layer by layer. But once I have this, I'm satisfied with what this looks like. I don't need to go back through Creo and do any changes. I just return my tray. Now from here is where we do our print to printer, if we have one of those supported. Otherwise, I can just go through and do the old standard method. Let's do a save as or STL here. Maybe go through, customize our export a little bit. We want to go through and mess with our chord height, our angle control. I usually choose 0 and 1 for these, but really it's all up to your printer and your specifications. Otherwise, just get this off to our 3D printer and get a 3D print from this. So that's how we utilize the additive manufacturing extension to put in those new lattices, have great control over how we can apply that. Going further, we can also utilize Creo Simulate to run through and do an optimization of that lattice. And then from here, get this off to our 3D printer in the exact manner that we want to within our tray. Now, just to wrap up here, I just have a few more slides. The whole goal with the additive manufacturing extension is just get a faster time to print. Go directly from our model into viewing how it's going to 3D print. If I need to make a change, let's just go back into Creo straight from there. Just an X click away from getting back into how I'm actually modeling this out, make that change, check for the printability again without having to deal with any exports again in any other software. Because the whole goal is let's get more prototypes out with less time involved and really just ensure that first time printing success. Using that validation, using the global interference to verify that this isn't going to break whenever it takes 15 hours to 3D print or 3 hours to 3D print or even an hour. Let's make sure that we don't waste any of that time because that time could be used to be prototyping something else. Overall, we want to be able to reduce your software maintenance. Having everything compact into within one software is obviously a lot easier than having 4 different packages or 2 different softwares that we're going back and forth between to get these things 3D printed. And just make full use of the printer capabilities. So especially with the supported printers, being able to choose our surface finish, the different colors, being able to get some complex lattices that we can't do with any other type of manufacturing method. Let's use that and let's design that way and get out to our 3D printers. And we just want to have more production parts. So get some customized production parts and some high quality ones that are going to be able to print on the first time. Now the current status of our additive manufacturing is that there is an initial printer integration capabilities within Creo 3 M40. So that was being able to set up your tray. So going forward into Creo 4, we have the lattice structure being able to be added. And going from Creo 4, there is plans to have additional printers. There's lightweight design tools, process simulations, seeing how this is actually going to build out, simplify our assemblies, and also minimize support. There's actually going to be support, or there's planned to be support for building. There's support within the software to build your support material within Creo. So, and there's a lot more planned. A lot of exciting things coming out of manufacturing as we continue to flesh this out going forward. Creo 4, Creo 5, there's a lot more plans to continue advancing upon this. But otherwise, that's all I have in terms of presentation material today. Now, I believe we have a few minutes here for a little Q&A if there's anyone on the call who has a specific additive manufacturing question for me. But otherwise, it was great talking to you guys all today.
Awesome. Thank you, Andrew. We did actually get in a couple of questions. Jordan Nowak asked, what is the cost of the extension?
I don't have any information on the costs. I'm sure our friends here at Tech 30 might be able to help you.
Sure. Okay.
Otherwise, I'm sure we can get that material out to you somewhere.
Yes, no problem, Jordan. We'd be happy to send you some information regarding that. And then one other question that we had is, what if the 3D printer I'm using doesn't have a direct integration with the software?
Yeah, so a lot of the time we're utilizing printers that, you might not have a Stratasys, you might not have a 3D Systems for one reason or another. There's a lot of printers in the market. You won't be able to do the print to functionality, but you can still go through, build your lattices, optimize within Creo, prepare your 3D print within Creo. All you're gonna have to do from there is just save it as an STL. The only functionality you're missing out from is being able to customize your surface finish and also being able to print directly from Creo. You can still save off as STL as you're used to.
Okay, awesome. Well, thank you so much, Andrew, for presenting today. Excellent presentation. And to all of our attendees, we will be posting this video to YouTube later today, so feel free to pass along to your friends and colleagues, and be sure to subscribe to our channel, follow us on Twitter and LinkedIn, just so that you can get information regarding upcoming webinar dates and topics. And then lastly, if you could please just stick around for 10-15 seconds after the webcast ends, just to fill out a survey, let us know how we did and what you liked. We really appreciate the feedback. And thank you again, Andrew, and thank you everyone for attending. Have a great rest of your day.
Thank you, guys.